atomic structure. Most of you will find this a pure revision of your junior science years. Now, to set a solid foundation for later, more intricate knowledge of atomic structure, I'd like you to pay attention to these 3 key points. Terminology of subatomic particles, understand relative scale of atomic mass, and to be able to calculate relative atomic mass based on its isotopes. Now, we know that the universe is made up of atoms, so the question is, what are atoms made up of? So they're made up of these 3 subatomic particles: protons, neutrons, and electrons. The protons and neutrons exist in a dense core at the center of the atom. This is called the nucleus. Okay. The electrons are spread out around the edge of the atom. They orbit the nucleus in layers called shells. The mass of these subatomic particles are very important to us. When they are measured in kilograms, they are given by our data book. As you can see, these numbers are very difficult to work with, arithmetically speaking. Therefore, scientists invented a relative scale. So we arbitrarily picked a carbon-12 atom, which has 6 neutrons, 6 protons, and 6 electrons. In that way, carbon-12 is assigned to have a mass of 12. Recall that there is no units for it because it's a relative scale. We arbitrarily say that carbon-12 weighs 12. So by division, each proton and each neutron gets 1 unit of relative mass. Now, so in conclusion, the relative atomic mass for proton and neutrons are assigned 1 each, while electrons in comparison are considered to have no mass. Okay. Sometimes you will find this nuclear symbol notation. X is the chemical symbol. A stands for the mass number, which is the bigger number. It consists of the addition of number of protons and number of neutrons. And Z is the atomic number, which equals to the number of protons. Okay? Also, in neutral atoms, the number of protons equal to the number of electrons. If you are asked to write such notation, remember the bigger number on top left, the smaller number on the bottom. The mass number will always be larger or equal to subatomic number. Here is how our periodic table arranges information: atomic number on top and mass number at the bottom of the chemical symbol. Here's the burning question though. Check out the mass number of the elements below. Aluminium 26.98, silicon 28.09. Well, since mass number is a mere addition of the number of protons and neutrons, shouldn't they be whole numbers? Where do the decimals come from?